All right, so in section 3, we're going to look at sampling, simple random sampling. So simple random sampling is where we take all possible items or people that are in the population. Okay, so simple random sampling is where we consider the entire population, and N, capital N, is the number in the entire population. And a lowercase n is the number in the sample. Okay? All right, so if we choose our sample in such a way that every person in the population or every object in the population has the same chance of being selected, then that's a simple random sample. The way that I would do that, if I want to do a simple random sample of Midland College students, I would number off every student at Midland College. Then I would randomly select, so I can use a random number generator. I can put all of the numbers in a hat and pull out. If I want a sample of size 30, pull out 30 names or numbers. Okay, so you select it by chance, and every person or item in that population has the same chance of being selected. Okay, so that is a simple random sample. Okay, other sampling methods that we want to look at are the stratified sample, a systematic sample, or a cluster sample. Okay, so a stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. Individuals within that stratum should be homogeneous or similar in some way. Okay, so let's go again with the example of I want to find a sample of all Midland College students. Okay, so I can separate them into, and usually they're already separated into some category, and I'm just using those categories. Okay, so think of categories that Midland College students are already separated into. How could you separate out? Yes. Okay, you could majors, freshman or sophomore. There's one really easy one. There's only two groups, male or female. Okay, so you could do that. So stratified are taking groups that are already in place, okay? And then what you're going to do is within each of those groups, you're going to choose a simple random sample, okay? So instead of doing a simple random sample, numbering off all Midland College students, you're just going to take the males and the females, number off all the males, get a sample of 30 of them. All the females, get a sample of 30 of them. Okay, that's a stratified sample. Okay, or you could do it by majors. Okay, if you do it by majors, you number off everyone in the different majors, and then you get a sample of 10 from each major or something like that. Okay, you want to try to make sure that your sample, every person in the population has just as much chance of being selected, so you have to be careful if you look at strata that are very different in size. Okay? All right. Let's look at a systematic sample. Okay, so another way of obtaining a sample is a systematic sample, and in that type of sampling selection, you select every kth individual from a population, and the first individual is selected from a random number between 1 and k. Okay? So, for example, maybe you go to a concert and you don't want to interview every single person that comes into the concert. And so instead, you're going to say, how about we interview every 10th person, but we're going to select a random number between 1 and 10. So maybe we put it 1 and 10 in a hat and pull out 3. So we start with 3, and then we do every 10th person. So 3, 13, 23, 33, 43 that are in line as they come in. Okay, and so that helps to prevent some bias, because maybe the person standing there with their clipboard doing these surveys sees number 10 in line and goes, ooh, he's kind of scary looking. I think I'll wait till the next person or whatever. Or, you know, people don't make contact with them, so that eye contact with them, so they skip that person and wait till someone who looks a little more friendly. Okay, so it prevents a little bit of that kind of bias. All right, any questions on systematic sampling? Okay, and then the last one is the cluster sample. Okay, so a cluster sample is obtained by selecting all individuals within a randomly selected collection of group or individuals. So, an example of clusters, so clusters again are groups that are already intact in some way. So in education, a lot of times that would be schools are already groups that are intact, or classes are already intact. So if we wanted to do a sample of Midland College students, maybe we use all 9:30 classes on Tuesday. Okay, so we look at all the 9:30 classes on Tuesday, we number off those classes. Then we randomly select, say, 5 of those classes, and we survey everybody in that cluster. Okay, so the difference between the stratified and the cluster is stratified, we get groups, and then we get a random sample from each of those groups. Cluster, we randomly select the group, and then we survey everybody in the group. Make sense? Okay. If you look on the PowerPoint, there is a visual that might help with being able to tell that difference too, and I believe it's in your book as well. Okay. So look at that in section 1.3. Okay, in section 1.4, we're looking at other types of sampling. And so one of those is a convenience sample. Okay, so a convenience sample is like if you have a TV station, say, call in and give us your opinion about something. Okay, people call in, or maybe somebody standing at the mall and just asking questions, or at the library or something like that, or at the student center asking some type of survey question. Okay, so convenience sampling is easy, it's cheap, and so people use it a lot, but there's a lot of bias in convenience sampling. So it's not very effective. Okay, anytime you see a study that's done using a convenience sample, you should be suspect of the results of that. Okay, and there's a time and place for that, because it is easy and cheap, but you just need to consider that it's not as effective. Okay. So for example, if I go to the student center and ask people their opinion about who they're going to vote for mayor or something like that, is that representative of the entire population of Midland? No. Who am I going to get if I stand at the Student Center? Midland College students. Who am I leaving out?
All of the rest of the community.
All of the rest of the community. So is that, if I stand there and ask the people who they're going to vote for mayor, and then I say, well, so-and-so is ahead by 20% or whatever, is that going to be legitimate? No. And that's what happens with the news media. A lot of times happened in the last election, is they do samples that are not representative of the population. Okay? All right. So we have biases in sampling. There are 3 types of biases. The first one is a sampling bias. Okay, so that means that the technique that I used to create the sample was flawed in some way. So it didn't give me a sample that was representative of the population. Okay, so that's called undercoverage, or because there are parts of the population that were not covered in your sample. Okay, so in the case of only asking Midland College students who they're going to vote for, there are parts of our population that were undercovered. They weren't part of that sample. Okay, so that's a sampling bias. A non-response bias. How many times have you received a phone call asking you to do a survey and you didn't do it? All of us, right? Okay, how many times have you been sent a survey in the mail or an email asking you to do a survey and you didn't do it? A lot of times, right? So that's a non-response bias. So who's going to fill out the surveys?
Just people that maybe work for that company.
Maybe people that work for that company. Maybe people that really have a strong opinion one way or the other, right? If you're really mad about something, you might fill out a survey because you want to complain, you want to be heard, right? So the problem with the voluntary response surveys is that not everybody will respond, and the ones that do are the ones that have a really strong opinion. Okay, so that would be a non-response bias. Okay, then there's also bias in people who respond. It's called response bias. Okay, so the types of response bias are interviewer error. So maybe the interviewer made a mistake in the way that they asked the question. Maybe they misrepresented answers. The wording of the questions could be leading. Sometimes you'll have a survey where it'll say, do you think we should raise taxes to better the education for the children of our community? I mean, the wording makes it to where if you say no, then you're saying the children of our community shouldn't have a better education, right? So the wording can be leading, or sometimes the order of the questions. Okay, there have been studies where they put the questions in one order and do the survey, and then they put the questions in a different order and do the survey and get different results. Okay, because maybe reading one of the questions made you think differently about the next question. So the order of the question can even have a response, or the order of the words in the question. Are you in favor or not in favor of raising taxes for education? So sometimes if you switch that around, are you not in favor or in favor? People tend to choose the first one more than they do this next one. Okay, so that would be a response bias. Then there's always data entry error. Okay, so the person either recording the data or putting it into the computer make an error. And then there are non-sampling errors and sampling errors. So non-sampling errors are a result of sampling bias, non-response bias, response bias, or data entry error, okay? And then a sampling error is one that is because of the way you chose your sample, okay? And it doesn't give a representation of the entire population. Okay, and then the design of experiments. This is the way that you're going to design an experiment. And we're going to look at describing the characteristics of an experiment, explaining the steps of designing an experiment, the steps of a completely randomized design, and a matched pairs design. So let's look at designed experiments. Okay, so when we have designed experiments, just a little bit of vocabulary in that. So remember, a designed experiment is a controlled study where we control who goes into which groups. We design it in a specific way. Okay, things that affect the response variable are called the explanatory variables or factors. Okay, we use those interchangeably, explanatory variables and factors. Okay, so, and then any combination of those factors that we put into a designed experiment is called a treatment. Okay, so we talked about the exercise or no exercise. That the treatment would be that they exercise an hour a day or whatever. Okay, the experimental unit is the person. One person is an experimental unit. Okay, usually when we're talking about people, we say subject, not experimental unit. Okay, but it could be that we are doing the experiment on rats or something else. Okay, so it doesn't have to be a person. The control group is a baseline. Okay, so we use that as the group that doesn't have the treatment. And then we're going to compare it to the group that we do have the treatment for. So the control group is the group that does not have a treatment. So an example of that, like if you had, say, you're doing some kind of experiment about educational success of kids that have had abuse, some domestic abuse or something like that. So you don't like go out and abuse part of the kids and not abuse part of the kids, right? That would be very unethical. But what you do is you get a control group of kids that you know have not been abused, and you use those as this is the way it would be without abuse, okay? And then you follow kids that have known abuse in their life and look at their educational records or whatever and see if there's some kind of correlation there, okay? All right, a placebo is an innocuous medication such as a sugar tablet that looks and tastes the same as the experimental medication. So we talked about the other day, if we wanted to test like Tylenol or something like that, we could take two groups or a group of people that all have a headache and put them into two groups randomly. And if one group we give Tylenol and the other group we give a tablet that looks, smells, everything like Tylenol, but it's just a sugar tablet. Okay, and so we do that because if people think they're not getting it or they think they are getting it, sometimes they feel better, even if they're not getting it, just because they think they got it. Okay, so that's called the placebo effect. If somebody has an effect, even though they're not getting the treatment. Okay, but we control that factor by giving everybody something where they think they got it. Okay? And so we have, when we do a placebo, we have what we call blinding in experiments. So that's where the person receiving the treatment doesn't know whether they're getting the treatment or not. That's blinding. A single blind is where the person in the experiment doesn't know whether they're getting the treatment or not, but the person doing the experiment does know. Okay? And then a double blind is where the person in the experiment and the experimenter, neither one of them know. So there's a third party that knows whether this person's getting the placebo or not. Okay? Because sometimes, as an experimenter, if I know that you're not getting the Tylenol and you have a headache, I might do something, my body language might be something to let you know this is not really Tylenol, but here, take it. Okay, so that's why they have to do a double-blind experiment sometimes. Okay? All right. So to design an experiment means to describe the overall plan of conducting the experiment. Okay, so here are the steps in conducting the experiment. First, identify the problem to be solved. Okay, so you need to be very, very specific in what the problem is that you want to solve. Okay, the second step is to determine the factors that affect the response variable. Okay, once the factors are identified, then we need to think about, is there a way to control some of those factors? So when we talked about doing a study on weight loss, okay, we said one of the factors might be what they eat. So is there a way for us to control to make sure everybody gets the same amount of food? Everybody gets the same amount of water. Everybody gets the same amount of sleep. Can we control all those factors so that the only difference is the amount of exercise? Okay? So determine the factors that affect the response variable. Then determine the number of experimental units. So you want to have as many people in your study as possible, because the more you have, the more effective your experiment is going to be. Okay? The more people you have, the more time consuming it is, the more costly it is. So there are limits to how much you can include in your study. Okay? So that depends on what your resources are, but you're going to determine the number of experimental units, and then step 4 is to determine the level of predictor variables. Okay, so the control, there are 2 ways to control the factors. One is you're going to set the level of the factor at one value throughout the experiment, and then set the level of the factor at various levels. Okay, so in the example of weight loss, like we might say, okay, we're going to do, this group is going to get 1,200 calories a day, this group is going to get 1,500 calories a day. They're both going to do, exercise, but this one's going to be 30, this one's going to be an hour. So you can set the controls at different levels if you, depending on what you're trying to accomplish. Okay, and then determine the level of, you also want to randomize. Okay, so when you put people into those treatment groups, you want to randomly select. Okay, so each person that comes in, if you have 2 groups, you're going to say, okay, draw a 1 or a 2. And they draw a 1, they go to that group. If they draw a 2, they go to that group. Okay? They may not end up having the same amount in each group if you do it that way, which is fine. Okay, and then step 5 is to go ahead and conduct the experiment. Okay, replication occurs because you're doing the treatment on more than one experimental unit, because you have several units in your, and then you want to collect and process the data. Okay. And then the last thing is to test the claim. Okay, and we'll talk more about testing the claim later on in the semester, but we'll test different claims. In fact, you're going to do a project where you test a claim. Okay. All right. So